Assalamu alaikum, girls. Okay, let us complete our lesson about friction. I'll ask you this question. In order to go faster, bike riders do all of the following except look at how do they sit. Why do they sit like this? To prevent the air resistance. They don't want the air to push them back because they go very fast. So what should they do? All the following is correct except one is not correct. Which one is not correct? They wear light clothes. They sit upright, يعني they sit upright واقفين. They put their heads down. Tuck their arms and leg in. يعني they tuck their all their body, they close it to each to become this shape. Do they tuck their legs and hands in together? Which one is not correct? For sure it is they sit upright. It is not correct for these bikers to sit upright. They should sit like this. They should tuck their arms and legs in, and they should put their heads down. So the wrong answer is that they shouldn't sit upright. They should sit like this. Okay, now what affects air resistance? Yalla, together. Faster objects will face more air resistance? Yes or no? Sure. Slower objects will face more air resistance? No, they will face less air resistance. Flat shapes will face less air resistance, like the parachute. It has less air resistance or more? Sure, it needs more, so this is not correct. Round and small, the streamlined shape, face less air resistance? Yes. Okay. Now we want to investigate friction in activity 10 point here in your book, 10.2. I want you to read it. Actually, it needs something. It needs a tool. I really don't have it. We used to have it in school. This tool, it measures the force. Now, I want you to look at your book and tell me, what do we call this tool? You have it in your book. We call it Newton meter. Newton meter. What does it measure? It measures the force here. It's written. I want you to underline it. This is very important. A Newton meter measures the force. Hala. Here, as you can see, it has numbers. And it has a hook. The hook is attached to a weight. Now this weight can be more or can be less. If the weight is more, if we put more coins here, the hook needs more force to push it. Yani, this is a rough surface. Suppose like this. I have this rough surface. Remember it? Okay, and suppose I have here this. If I have a Newton meter and I hang it here, now, do you think on a rough surface the friction is less or more? طبعا it is what? It is more because it's rough. طيب. Now, I have these coins. If I put more coins, if I make more weight, I'm making it heavier. Do you think now it can move slower or faster? For sure it needs more force. The hook here needs more force. If you catch it from here, you need more force if the weight is more. Okay? So two things affect the Newton meter or the force. What affect the friction? Okay? Now, as you can see, we have a wooden plate with a nail fixed on it. We will fix the hook of the Newton meter on the nail and try to push the plate. Can you see? It reads 1 gram. Now we will put weights on the plate, look at the reading. It reads 25 grams. It needs more force to push it. Now we will put more weight and pull the Newton meter. You can see how much force it needs. It needs bigger force, 65 grams, as you can see. Answer the questions as you saw. Whenever you put more weights, it needs more force. Okay, type. The question is, what is the effect on the friction force of increasing the weight? The friction becomes, if I put more weights here, that pushes the surfaces together, does it need bigger force or less force? As you can see, more force, more weight needs more force. This is the answer. You can write this in your notebooks. This is a homework. Bigger weights make more friction. Heavier weights make more friction. This is the answer. Question number 2. What is the effect on friction of different surfaces or adding water or oil? And if I have a surface, rough surface, smooth surface, if I add water, if I add oil, what is the effect? I think we answered this last time. Smooth surfaces make less friction, and also adding oil and water makes the surfaces smooth, and rough surfaces make more friction. Now our last objective is to figure out the circular motion. Look at these here. The dryer and the washing machine, they move in circle. Okay, when they move very fast, the clothes will stick here, will be closer to the surface of the dishwasher. Also, the planets, they rotate around the sun. This is a circular motion. Also, the satellites, they rotate around the earth. Also, this is a circular motion. Also here, this man is trying to hold a force, this ball, okay? He's trying to make a circular motion. So a circular motion, it's a motion of an object in a circle at a constant speed. سرعة ثابتة. Here, always they need to stay at the same speed. سرعتها لازم تكون ثابتة, even if it's very fast. Now, if for example, the planet move a little bit faster, it can go away from its orbit. Also here, the man, if he keeps on rotating the ball faster and faster, and suddenly he leave this string, the ball will no longer move in circle, it will move away. Move to activity 10.3. The activity is asking you to bring a string, خيط, and a cotton reel or rubber band. Rubber band, a piece of rubber. You can, like this, and go in circle. When you do this, when you move the rubber band in a circle, you can feel in your hand that the string is pulling you. Something is pulling your hand. Now, when you feel this pull of the string and your hand is at the center of the circle, this force that pulls the string out, it is the force needed to keep the rubber moving into a circle. Now, when you feel this pull of the string and your hand is at the center of the circle, this force that pulls the string out, it is the force needed to keep the rubber moving into a circle. Okay? So, in B, they're asking you to suddenly... Now, another question. How can a car go around the roundabout? What should the driver do? He should put a force to the right. This force is called sideway force. قوة جانبية. He will catch the steering and make a force to keep on going in a roundabout. And he should keep catching the steering So the force, the sideway force, will keep going the car around the circle. Okay, so there always should be a force in the center that keeps things going in a circle, just like this car, just like a rubber band with your hand. Your hand is at the center. This is the force. What do we call the force that points towards the center of the circle here? The force is going this direction to the center of the circle. What do you think we call it? Do we call it centripetal force, gravity, or friction? أكيد it is called centripetal force. I want you to underline it. It is very important here in your book, page 192. Centripetal force is, underline it in your book. This force points towards the center of the circle. It is called centripetal force. Now, roller coasters are example of a circular motion. Now, when people go upside down, why do they don't fall? ليه? Because there is a force at the center of the circle that push them out. This force, the centripetal force, that keeps them in their places even if they are upside down. Again, this force is called centripetal force. Centripetal force happens when objects move in circles. Here, now in the bicycle, why do bicycles have these spokes? These are called spokes. Okay, you have this in your book. Here, these are called spokes. These rods are called spokes, يعني rods. Why do the tires of the bicycle have these spokes? It's exactly like the string here. Why? They give the push to the center, the centripetal force. They provide the turning force. They need the turning force to keep going around. Okay, so this is the center. The forces are going to the center of the circle. So they provide the turning force needed to move in a circle. Exactly, they have the same job as this string when you move the rubber band in a circle. Okay, so they provide turning force needed to move a circle. It's written in your book, and I really want you to underline it. The spokes of the bicycle wheels provide the turning force needed. Okay, now if the tires are wet, there's water in the street. Do you think the water will move in a circle with the tire? The tire will be wet. But this water, do you think it will move in a circle? No, it won't, because there is no force that hold the water to keep going in a circle. Always, as you can see, when there is a circular motion, the water will go in straight lines. Okay, it will not keep going. I'm talking about the water, not the wheels. The water is going in straight lines because there is no force to hold it to keep going in a circle. What will happen to the water? The water will go in straight lines. If there is a force that can take them to move in a circle, they will. But there is no force, so they will go in straight lines. That's why in bicycles, they always put something called mud guards or fenders. Always you can find that there is a piece of sheet or rod or metal here at the back of at the back of the tires. Why? It prevents the water from getting the rider wet if he moves through water like this. If a rider is moving over water, the water will go in straight line. That's why they put some fenders اوكي الحديدة مثل اللي بتكون على موجودة على العجل ليه the water it will hit the water and that's why the water will not let the rider go wet. okay so fenders بنسميها fenders الحديد اللي موجودة at the back of the tires of the bicycle بسموها fenders أو mud guards. So fenders or mud guards protect the cyclist from water. You have it here. It's important. Also, I want you to underline it. This is called mud guards. What is the function? What is the job of mud guards? You have it in the PowerPoint. It prevents or protect the cyclist from water. I want you to, this is the homework. It's in page 193, question 1, 2, and 3. Now, question 1, describe what might happen if a car tries to turn a corner too quickly on a slippery road. And I will explain the question and I want you to answer it. Search in the net, I don't know, you have to answer it. Suppose that there is water, there is snow. If the car is very fast and it wants to turn very fast, what will happen to the car? Okay? Question 2, draw and label diagrams. I want you to draw and label diagrams to show the direction of the frictional force needed from the road acting on a bicycle's tires. يعني draw a cyclist, show the wheels, show where is the force, driving force, where is the friction force. Here the cyclist is turning in a corner, يعني he's going around, and this is the centripetal force that pushes to the center. Well, is the friction will always be to the opposite direction. When this, I'm explaining this very fast because I want you to search and I want you to learn. When the cyclist uses both brakes to stop quickly, how is where's the direction of the force will go bigger? What would happen to a motion of objects moving in a straight line if there is no friction and no air resistance? Suppose anything, a car, anything that moves in straight lines, but there is no friction and no air resistance, what will happen to this object?